In the year 1943, a new machine appeared in the skies, over occupied Europe. To the seasoned and supremely confident fighter aces of the German Luftwaffe, it was an absurdity, a corpulent target that defied every known philosophy of aerial warfare. They looked upon its massive fuselage, its thick wings, and its somewhat brutish appearance, and they gave it a name that was both dismissive and oddly descriptive: Der Krug, the Jug. They believed it to be a joke, a clumsy product of a distant industrial power that had never truly understood the brutal calculus of a real dogfight. They were prepared to mock it, to tear it apart with their precise German cannons, and to add its silhouette to their growing tally of victories. But then, a fateful event occurred. An accident of history. One of these very same jokes, through a cruel twist of navigational error or the simple caprice of war, mistakenly landed at a German-held airfield, almost entirely intact. Suddenly, the object of their scorn was no longer a distant target in a gun sight, but a tangible, physical specimen sitting before them. And as the most brilliant engineers of the Third Reich began to dissect it, to peel back its metallic skin layer by layer, the laughter died in their throats. Their confidence began to erode, replaced by a creeping sense of awe, and then by a cold, sobering realization. What they discovered inside that metal shell was not merely a fighter plane, it was an indictment. It was a prophecy written in alloy and steel, revealing with undeniable clarity why, despite their early victories, despite the genius of their designers and the skill of their pilots, the thousand-year Reich was already on an irreversible path to defeat. This is not just the story of the P-47 Thunderbolt. It is the profound lesson of how a modern, industrial war is truly won, not by courage or tactics alone, but by the relentless, overwhelming force of the production line and the bottomless well of resources. Before we delve into the forensic examination that so profoundly altered the German perception, we must address a point of historical contention, a detail that astute students of history often raise. The common narrative holds that on the 7th of November, 1943, Second Lieutenant William Roach, running dangerously low on fuel during a flight over the English Channel, set his P-47, nicknamed Beetle, down on what he mistook for an Allied airfield in France. The problem, of course, is that in November of 1943, no such Allied airfields existed on French soil. The Great Normandy invasion was still more than half a year away in the future. So, what is the truth? The truth, as is often the case in the fog of war, is likely more complex. The capture of Roach's Thunderbolt is a confirmed historical fact, documented by reports from both sides. The precise reason for the landing, however, remains a subject of debate. It may have been a case of severe disorientation caused by bad weather and a faulty compass. It may have been a fatal error in ground identification. But whatever the specific cause, the final result was immutable. The Luftwaffe now possessed what it had desperately wanted: a pristine, fully functional Thunderbolt, ready to yield its secrets. This leads to the next logical question, one that is frequently asked. Why did the pilot not bail out? Why risk letting an advanced weapon fall into enemy hands? The answer to this question is the very key to understanding the entire story. To the American engineers and strategists, the P-47 did not contain a single, game-changing secret technology. It had no stealth radar, no jet engine, no magical device that could be copied to turn the tide of the war. Its true power, its real secret, did not lie in some singular, replicable invention. Its power was in the very things the Germans could see and touch and measure. The superior quality of its materials, the unimaginable scale of its manufacturing, and an entirely different engineering philosophy, one born of abundance rather than of scarcity. The Americans did not fear the Germans copying one P-47. They did not fear it because they knew a fundamental truth. Even with the most detailed blueprints in hand, the Third Reich simply could not build it on a scale that would matter. They lacked the specific alloys, they lacked the tooling, they lacked the industrial capacity. And that was the first, most painful, and most profound lesson that the German engineers were about to learn as they began their work. Prior to the capture of Beetle, The German understanding of the P-47 was forged in the crucible of aerial combat. Their combat reports, written by battle-hardened aces, were a mixture of contempt and confusion. Compared to their own nimble Focke-Wulf 190s or their agile Messerschmitt 109s, the American Thunderbolt seemed an anomaly. "It is simply too large," they wrote in their reports, noting its maximum takeoff weight of nearly 13,500 pounds, substantially heavier than the 10,800 pounds of an FW-190A. The German pilots observed that its rate of climb was poor, especially at lower altitudes, and that it handled sluggishly at the medium altitudes where most combat occurred. In the swirling, close-quarters turning fights that the Germans had perfected into an art form, the P-47 was a disappointing opponent. At 15,000 feet, a skilled German pilot could easily turn inside the Thunderbolt, slip onto its 6 o'clock position, and turn the jug into a ball of fire. Their initial assessment was clear. This was an inferior design, perhaps suitable for bomber escort where it could use its speed, but no match for a purebred German fighter in a traditional dogfight. Yet, woven into this dismissive narrative were troubling details, inexplicable contradictions that unnerved the analysts at Luftwaffe High Command. Pilots described with a sense of disbelief how they had poured accurate bursts of 20mm cannon fire into the Thunderbolts, hits that would have shredded a 109, only to see the massive American plane shudder, belch a stream of black smoke, and then stubbornly fly on, limping back to its base in England. Its durability seemed to defy logic, and then there was something even more frightening. When a Thunderbolt pilot decided to break off combat, he would often perform a maneuver that left the Germans utterly helpless. He would roll the aircraft over and plunge into a vertical dive. In that dive, the P-47 transformed. It accelerated with an almost unnatural ferocity. No German aircraft, not the FW-190 and certainly not the Bf-109, could keep pace. It would simply vanish into the blue abyss below, leaving the German pilots staring after it with incredulity and a growing sense of unease. There was some mystery locked inside this machine, some hidden power that they could not comprehend from a distance. The man tasked with unlocking this mystery was Hans-Werner Lerche, one of Germany's most elite test pilots. Lerche was not a typical combat pilot. He was an engineer by training, an analyst, a man who could feel and understand an aircraft from the inside out. When he first climbed into the cockpit of the captured Beetle, he was immediately struck by its complexity. German cockpits were models of minimalist efficiency. This American cockpit was another world entirely. It seemed to have twice the number of gauges and switches as our own fighters, Lerche would later write. He was confronted by an array of complex automated systems, particularly for engine management, tasks that German pilots had to constantly perform manually with adjustments to the throttle and fuel mixture. When he fired up the 18-cylinder Pratt & Whitney R2800 double wasp engine, he did not hear the sharp bark of a Daimler-Benz or the familiar roar of a BMW radial. Instead, it was a deep, powerful rumble, the sound of immense power held in check. On takeoff, Lerche felt exactly what his comrades had reported. At low altitudes, the aircraft felt heavy, ponderous, and slow to respond. But Lerche, with his scientist's curiosity, did not stop there. He methodically pushed the aircraft higher, past the 15,000-foot mark, then to 20,000 feet, and then, somewhere above 20,000 feet, a metamorphosis occurred. The aircraft seemed to shed its heavy, earthly skin. In the thin, cold air where German engines began to starve for oxygen and lose up to 30% of their power, the R2800, nourished by its special system, was still roaring at its full rated output. Lerche pushed the throttle forward and felt himself pressed back into his seat by an acceleration he had not thought possible at this altitude. The aircraft had transformed. It dove like a bullet, easily exceeding 500 miles per hour. Its roll rate, a weakness at lower altitudes, was now surprisingly crisp and authoritative, even matching the famously agile FW-190. The first shockwave of understanding hit Lerche. The Luftwaffe's initial assessment was not just wrong, it was catastrophically wrong. They had been fighting this monster in the wrong arena, at the wrong altitude. But the great question remained, Why? The answer lay not in the sky, but deep within the metal guts of the machine, waiting for the scalpels of the engineers at Rechlin. At Germany's premier aviation testing facility in Rechlin, the autopsy began. The German engineers, renowned for their meticulous precision, systematically disassembled the Beetle. The heart of the beast, the Pratt & Whitney R2800 engine, was the center of their focus. It was a marvel of engineering, but it was not the engine itself that left them breathless. It was its respiratory system, the turbo-supercharger, that seemed to come from another world. In theory, the German engineers understood it perfectly. They were, in fact, developing and testing similar systems in their own laboratories. But here, before them, this was not a fragile, expensive, experimental prototype. This was a mass-produced, robust, and reliable system, installed as standard equipment on thousands, and soon tens of thousands, of aircraft. The entire system was a masterpiece of industrial engineering. Hot exhaust gases from all 18 cylinders were carefully collected and ducted through complex insulated pipes that ran along the fuselage. This stream of hot gas spun a turbine at incredible speeds. This turbine, in turn, drove a centrifugal compressor, which scooped up the cold, thin outside air and compressed it to a tremendous pressure. But compressed air becomes very hot, so the Americans added another step. This stream of hot compressed air was ducted through an intercooler, a type of radiator for the air, before being fed into the engine's own supercharger. The result was a cool, dense charge of compressed air being forced into the cylinders, allowing the engine to maintain its sea-level horsepower at altitudes where the natural atmosphere was nearly a vacuum. To build such a system, the Americans needed things that Germany was running desperately short of. They needed special alloys, rich in nickel and chromium, that could withstand the extreme temperatures and stresses of the turbine. They needed manufacturing processes with microscopic tolerances to ensure everything fit together perfectly. They needed millions of reliable components, from bearings to regulators, that would function flawlessly under the brutal conditions of combat. The Americans had not only solved all of these complex problems, they had turned the solution into an assembly line. As the German engineers analyzed a fuel sample remaining in the tanks, another shock awaited them. The standard American aviation fuel had an octane rating of 130, with premium grades reaching 145, vastly superior to the best German B4 fuel, which hovered around an 87 octane rating. A higher octane rating allows an engine to run at a much higher compression ratio without the destructive effects of knocking or detonation, thereby producing significantly more power. Many have argued that the Messerschmitt 109's engine, with its advanced direct fuel injection system, was technologically superior. And, in a vacuum, that is a valid point. Direct injection was a brilliant engineering solution to the limitations of carburetors and to optimize performance with lower quality fuel. But this is precisely where the fundamental difference in national philosophies was exposed. The German philosophy was, we must engineer clever solutions to deal with our limited resources. The American philosophy, it seemed, was, why design a complex engine to run on bad fuel when we can produce millions upon millions of gallons of the best fuel in the world? Germany's war economy was heavily dependent on the costly production of synthetic fuel from coal and on the limited and increasingly vulnerable supply of crude oil from the Ploiești fields in Romania. The Allied strategic bombing campaign against these facilities was slowly but surely strangling the German war machine. America, in contrast, sat upon a veritable ocean of oil. This difference did not just affect the performance of an individual aircraft in the sky. It affected the entire system. It determined how many hours a new pilot could be trained. By the end of the war, a newly deployed American pilot might have hundreds of hours of flight time, while a young German pilot might be sent into combat with only a few dozen precious hours, a direct result of the crippling fuel shortages. The dissection continued to the armament and armor. 8 M2 Browning 50 caliber machine guns, 4 in each wing, with a total ammunition load of 3,400 rounds. When all 8 guns fired simultaneously, they produced a wall of lead capable of shredding anything in its path. And then there was the armor plate. Over 200 pounds of high-quality steel was strategically placed around the cockpit and critical systems like the oil cooler and the turbocharger. The pilot sat in what American designers called an armored bathtub. To German designers, who had to shave off every possible kilogram of weight to maximize speed and agility, this was an unacceptable extravagance. But to the Americans, the philosophy was different. They were willing to trade a small amount of performance for the life of the pilot. A pilot was a costly, highly trained asset. A pilot who survived could fight another day. A plane that was shot down, with their production capacity, it could be replaced in a matter of days. Every last detail, from the quick-release fasteners that allowed mechanics to easily access components for field maintenance to the consistent quality of every spark plug, told the same unassailable story. This was the product of a nation not constrained by scarcity. They did not have to cut corners. They did not have to use substitute materials. They had built the absolute best machine they could possibly conceive, and they were building it in numbers that bordered on the fantastical. The detailed technical reports from Rechlin, filled with charts, data, and dispassionate analysis, were sent to the Luftwaffe High Command, and as the generals and strategists read them, a chilling picture began to emerge. The problem they faced was no longer one of aerial tactics or individual design superiority. The problem was now one of mathematics, an industrial equation for which they had no solution. Let us be clear about the numbers, which are often a source of confusion. The staggering figure of 96,000 American aircraft was the peak production of ALL types of aircraft fighters, bombers, transports, and trainers in a single year, 1,944. But even if we narrow our focus to just fighters, the picture remains just as overwhelming. Over the course of the war, the United States produced more than 70,000 fighter aircraft alone. Let us look at the breakdown of that number. The United States produced 15,683 P-47 Thunderbolts. At the same time, they also produced 15,486 P-51 Mustangs, 10,037 P-38 Lightnings, along with tens of thousands of naval fighters like the F-6F Hellcat and the 4U Corsair. For comparison, Germany produced a total of approximately 34,000 Messerschmitt 109s throughout its entire service life, across all variants. The disparity becomes even starker when we look at the heart of these machines, the engines. Pratt & Whitney and its licensees like Ford produced over 125,000 R2800 engines. The production of this single American engine type exceeded the total combined production of Germany's two primary fighter engines, the BMW 801 and the Daimler-Benz 605, which together numbered around 103,000 units. This was the moment of dawning horror for the German engineers and generals. They were not just fighting the United States Army Air Forces, they were fighting General Motors, they were fighting Ford, they were fighting Chrysler, and they were fighting the full, unbridled industrial might of an entire continent untouched by the devastation of war. They were facing a nation where factories could run 24 hours a day, 7 days a week. A nation where the supply of aluminum, steel, rubber, and oil was, for all practical purposes, limitless. They were facing the arsenal of democracy. Germany, in its constrained reality, had sought to achieve victory through clever engineering and optimization. America achieved victory through overwhelming scale and abundance, and no amount of engineering genius could bridge an industrial gap of that magnitude. The invaluable intelligence gleaned from the captured P-47s was quickly synthesized and translated into tactical recommendations for the pilots at the front. Memoranda were distributed, outlining new rules of engagement. Engage the P-47 only at altitudes below 15,000 feet, where our agility is superior. Under no circumstances should you follow a Thunderbolt into a dive. It is a race you cannot win. You must press your attacks aggressively and concentrate your fire. Do not assume a few hits will bring it down. Say in Klayler. This advice undoubtedly saved the lives of many German pilots, but it was a tactical balm on a strategic wound that could not be healed. It was like teaching someone how to dodge a single raindrop while they were standing in the middle of a tsunami. For every P-47 shot down, 2 or 3 more rolled off the assembly lines in America to take its place. For every experienced German pilot lost, an irreplaceable wealth of combat experience was lost with him. The United States, conversely, had a massive training system, fueled by a near-endless supply of gasoline, to produce tens of thousands of pilots who were good enough in numbers that would eventually overwhelm any opponent. As the P-51 Mustang, with its superior range and performance, began to appear in vast numbers in 1944, and gradually took over the primary role of escorting bomber formations deep into Germany. The story of the P-47 was far from over. Instead, it entered a new chapter, one in which it once again proved the unique wisdom of its American design philosophy. The very characteristics that made it somewhat ponderous in a turning dogfight, its ruggedness, its heavy armor, and its powerful armament now transformed it into one of the most effective ground attack aircraft in history. Armed with bombs, rockets, and its 850 caliber machine guns, the Thunderbolts rained destruction upon the German war machine on the ground. Gun camera footage from this period shows a relentless onslaught, with P-47s strafing train convoys, blowing up tanks, and annihilating truck columns. The official statistics, even if prone to some exaggeration, paint a picture of utter devastation. Over 86,000 railway cars, 9,000 locomotives, 6,000 armored fighting vehicles. To the German soldiers fighting desperately on the ground, the distinctive deep rumble of an approaching R-2800 engine was no longer the sound of a battle. It was the sound of the apocalypse. The once derided Jug had truly become a juggernaut, an unstoppable force of destruction, both in the air and on the ground. And what became of the key figures in this story? Second Lieutenant William Roach, the pilot who had inadvertently started it all, and Lloyd Hathcock, another pilot who had also mistakenly landed a P-47 in enemy territory, both survived the grueling months in prisoner-of-war camps and returned home after the war. The test pilot, Hans Werner Lurch, almost miraculously survived the war despite having flown 125 different types of aircraft, including numerous captured Allied planes, without ever having a serious accident. It is his meticulous, objective notes that have given us this priceless insight into the German perspective. As for the captured Thunderbolts themselves, they were rediscovered by Allied forces at the end of the war, sitting silently in German hangars. After being studied by Allied technical intelligence teams, they were eventually broken down for scrap. They had completed their final mission, not on the battlefield with guns and bombs, but on the enemy's analysis tables, serving as a quiet testament to a war that had been decided long before the final shots were fired. Ultimately, the story of the captured P-47s transcends the specifics of aeronautical engineering. It is a fundamental, enduring lesson about the nature of modern industrial warfare. The Third Reich entered the war with arguably the most sophisticated air force in the world, with the best-trained pilots and with aircraft designs that were ahead of their time. They won stunning victories in the early phase of the war through tactical innovation and technical superiority. But they lost the war of the assembly line, they lost the war of the oil wells and the ore mines, they lost the war of numbers. The P-47 Thunderbolt was not the most perfect aircraft ever built. It was not as agile as a Spitfire in a low-altitude fight. It did not have the long legs and elegant grace of a Mustang, but it was a supremely effective machine, designed to absorb punishment, to be easily repaired in the field, and most importantly, to be produced in quantities sufficient to simply crush any opposition through sheer, brute force. It was not a fencer's rapier, it was an industrial sledgehammer, and when the German engineers looked at every bolt, every weld, every component of that machine, they saw more than just an airplane. They saw their own, predetermined future. The P-47 was more than a weapon. It was a 15,000-pound invoice, delivered at over 400 miles per hour, for an industrial debt that the Third Reich, with all its engineering brilliance and all its martial courage, could never hope to repay.